Okay, this is like 1.6 part 2. This is more angle pair vocab. So we're going to kind of use the same vocab words that we used yesterday with our angle pair vocabulary. And then we're also going to add one to it. We're going to add angle bisector to the mix and talk about how we would use angle bisectors to solve for missing measures here. So here we go. First example, we might see pictures like this. So we'll say this is Q, P, R, T. And maybe this, they say, is 2x plus 18. And this angle is 4x plus 12. And we want to know to find measure of angle QPT and measure of angle TPR. Okay, so we want to use our knowledge of what this picture tells us about what those two angles are going to add to. So if I were to add those two angles together, what am I going to get? You think you've got it? Type it in the chat. There we go, 90 degrees. Yeah, this little square in the corner tells me that it's going to add to 90. It tells me that these angles are complementary. So, and they might even give us that in words in the problem too. They might say that these two angles are complementary. They might not. They might just give us the picture though, and we need to be able to tell from both. So we would set up an equation, 2x plus 18 plus 4x plus 12 equals 90. So this is going to look a lot like the problems that we did with just regular adjacent angles, except using notation here to determine that they're going to add to 90 instead of being told what they're going to add to. Okay, so next step, combine your like terms. 2x and 4x gives us 6x. 18 plus 12 gives us 30. Then we're using our algebra here to solve, minus 30 on both sides. We're left with 6x equals 60. Dividing by 6 on both sides, we get x equals 10. And then we go back to the top and we notice that they asked us to find the measures of the angle. So we need to make sure we go and plug those things, plug x into those two angles. So we know angle QPT is 2x plus 18. So 2 times 10 plus 18. We know angle TPR was 4x plus 12. So 4 times 10 plus 12. And then 2 times 10 plus 18 is 38. 4 times 10 plus 12 is 52. And when you're done, an easy way to check yourself is that these two angles should add up to 90. And in this case, they do. If they don't add to 90 at the end, then something went wrong, either when you set up your equation or when you solved for x or when you plugged it in. Somewhere in there, something went wrong if they don't add to 90 at the end. Okay, so that's one type of question that we could see. Another type that we could see might look something like this, a little bit more like what you saw on IXL C3 last night. So I'm going to draw a picture here to go with it. Okay. So they could give us a picture like this and ask a lot of different questions about this picture. I'll give everyone a sec to draw the picture. The angles here should be 37 degrees, 40 degrees, 50 degrees, and then a right angle right here. Okay. So they could ask us something like, name a pair of adjacent supplementary angles. Name a pair of adjacent supplementary angles. Okay, so that means we want them to be next to each other, and we want them to add to 180. Does anyone remember the other name for adjacent and supplementary at the same time? There was a vocab word for this. You can look back at your notes from yesterday. What was the vocab word that meant adjacent and supplementary at the same time? There we go. Yes, linear pair. So this is just another word for linear pair. And that's what we're looking for over here in the picture. Okay, so there's a couple different linear pair options that we could name here. I could start with QWX, this right angle here, and then also have QWZ, this other angle right here. Those two would be a linear pair. So we could have angle QWX and angle QWZ. That would work. Or we can have something involving XWY. We could use that angle and this one. So that would be ZWY. So we could use these two, or we could use these two. Either one. If they wanted adjacent and complementary, we'd be looking for ones that add to 90, so maybe like those two. But yeah, that's another kind of thing that we could see. All right, another example here. If we've got a picture going again, we're going to start with a line. And then we'll do another line here. And we'll do a ray. And then we'll do a couple rays. So we have angles 1, 2, 3, 4, and 5, 6, 7, 8, 9, and 10 in this picture. Okay. So we could be asked maybe, are angle 5 and angle 3 vertical? Or how about angle 2 and angle 4? That's one question we could be asked. What do we think? Are angle 5 and angle 3 vertical in that picture? Kind of a tough distinction. Christy thinks no. Anyone else agree? Owen agrees. All right, I agree with both of you. No, 5 and 3 are not vertical. And the reason for that is that 5 and 3 are made by different objects here. 3 is made by 2 crossing lines here, but 5 is made by a ray coming off of the line. So although they're across from each other, they are not vertical. And you can also kind of tell by the size. 5 looks smaller than 3. So that's another way you can tell. 5 and 3 are not vertical. What about 2 and 4, though? What do we think for those? Are 2 and 4 vertical? All right, David and Nolan both think so. Mallory thinks so. Shai thinks so. I would agree with you guys. Yes, 2 and 4 are vertical. They're across from each other directly, and they're made by crossing lines. So if the sides of my angle come from the same lines, then they're vertical here, and they're across from each other. So 2 and 4 would be a situation where, yes, they are vertical. Okay. And then another type of question we could see would be something like we had on our warm-up. We could say something like, name linear pairs involving angle 3. Name linear pairs involving angle 3. Okay. Well, first of all, angle 3 and angle 4 would be one of them. What would the other one be? Angle 3 and what other angle? Yep, angle 2. Angle 3 and angle 2 would be the other pair. So those would be both of our linear pairs involving angle 3. 3 and 2 and 3 and 4. Okay. So those are some types of questions that we'll see on our homework today that involve the angle pair and angle relationships that we saw yesterday in class. We're going to add one more angle relationship, and it's called the angle bisector. So, new piece of paper. Or I need a new piece of paper. Maybe you don't. Maybe you write smaller than me. All right, kind of shifting gears here, we're going to talk about angle bisectors. Angle bisectors. So we had segment bisectors back in the beginning of chapter 1. And remember, a segment bisector cuts a segment into 2 equal pieces. It divides it equally in half. Angle bisectors do the exact same thing, but for angles. So an angle bisector is a line or ray that cuts an angle into 2 equal or congruent angles. Okay, so it cuts an angle into 2 congruent angles. So for example, if this original angle here, we'll say it is 102 degrees, and we'll call it A, B, C. Okay. If ray BR is the bisector of angle ABC, Find the measure of angle ABR. Okay, so ray BR is my bisector. And so if I know this whole angle ABC is 102 degrees, well, then all I have to do is go 102 divided by 2, which is 51. And then both of these angles would be 51 degrees. So that would tell me that measure of angle ABR is 51 degrees, because that's just this half right here. So that bisector is dividing the angle equally in half. Okay. So that's one possible type of question that we could see. Another possible type of question we could see, kind of stepping it up one more level here. If we had something similar here. Let's see, we'll go with we'll say that this is x plus 14, and this is 2x minus 6. And we're going to be told that QS is the bisector of angle PQR. And we want to find the measure of angle SQR. I'll give everyone a moment to write that. Okay. So this is another case where since it's cutting it into two congruent equal angles, that means that this ray here, it says 2x minus 6. Thanks, Christy. 2x minus 6 here. And this says x plus 14 right here. So if I have, this is cutting my angle into two equal pieces, that means that these two angles are the same. They are equal to each other. So what I'm going to do is, just like if it were vertical angles, this is another angle relationship where the angles will be equal. We're going to go 2x minus 6 equals x plus 14 for our equation. Okay. So we set them equal, and then we just solve for x. So minus x on both sides. Plus 6 on both sides. And we should get x equals 20. Then we want to know what the measure of angle SQR is. So we know angle SQR is x plus 14. So that would be 20 plus 14, which would give me 34 degrees. If they ask me what the measure of angle PQS is, would I have to plug it back in and do all that again, or do I know already? What would angle PQS be? What do we think? Yeah, also 34. Because I know that these two angles are the same, right? So I don't have to go and plug 20 into this again, although I could just to double check. If I wanted to, I could find, okay, measure of angle PQS is 2 times 20 minus 6, which is 40 minus 6, which is 34. So we could go and double check that way. That's a good way to check yourself. They could also ask us at the very end, what is the measure of the whole thing? What is the measure of angle PQR? So if I know that this one is 34 and this one is also 34 now, then I could just add them together to get the whole thing, right? So measure of angle PQR would be 68 because I would just add the two together. So those are additional things that we could be asked using angle bisectors. Again, kind of the basic case is up here where you either have to take this big angle and divide it by 2 to get the small angles, or if you were given the small angles, you could multiply them by 2 or add them together, whichever you prefer, to get the big angle. And then down here in this case where we have the two angles that have been divided in half already, we can set those equal to each other and solve for x and then plug it back in to find our missing angles. So that's pretty much how we deal with angle bisectors here. It's very similar to what we did with segment bisectors. Okay, so at this point, are there any questions, any numbers that we're not sure where they came from, or steps we're not sure why they happened? Anything like that? Okay. If at any point you do, make sure you either unmute yourself and say so or type in the chat. We're going to move into the part where we get our homework assignment, which today is going to be in big ideas. So let's go to Google Classroom. Assignment for today. And we're going to post that. Okay. So again, for big ideas, keep in mind, I can see how long you spent on it. I can see if you used any of the supports to check yourself or anything like that. And I can also see if you just did not even attempt a problem and turned it in anyway. So please make sure that you are using those supports, checking your answer, things like that. If you're having trouble with a question, please come and either talk to me or use one of their live tutors, whatever you feel comfortable doing. But don't just breeze through it in 5 minutes and not check answers or do anything like that, because that will not get you credit. Okay, so looking at this, click on the assignment, log in with Clever. If the logging in with Clever from the link here does not work, sometimes it doesn't. I've had a few people doing that lately and realized that logging in with Clever via the Google Classroom link doesn't work very well for some reason. What you can do instead is go to the Symbaloo page at the beginning of your Chromebook. And remember, you can always click on Clever from there and then click on Big Ideas after that. So you can always click on Big Ideas. You might have to scroll down to find it, but it'll be there, Big Ideas. And then you can click on your assignments out of there if you would like to. So that's just another option if you were unable to get to it. But anyway, here's what your assignment looks like. We have 15 questions today. And some of them are kind of like the stuff we did yesterday, and some of them are like the stuff that we have that's new today. So you've got time now to work on it in class. If you have questions, feel free to come back on and we'll talk together about it. Or feel free to come to office hours if you don't realize until later that you have questions. And they're mowing the lawn outside the portable, so that's fun. And then please come back at 10:55 either way, because we do have HSBP today. So come back at 10:55 for HSBP. You guys are free to go and start working.